Yep.
Roller coaster. What do real-life engineers factor into building a roller coaster?
Gravitation. So once a roller coaster disengages from the initial chain lift or propulsion force, gravity ensures that it completes its course along the track. Gravity is also felt by riders in terms of both positive and negative forces that seem to push the riders deeper into their seats or pull them out of them. So basically, when you're on a roller coaster and you feel like you're about to fly out of your seat, that's actually gravity.
Potential energy and kinetic energy. The higher an object is off the ground, the more potential energy it has. That is, potential to gain speed as it falls. As it falls toward the ground, that potential energy changes to kinetic energy or energy of motion. It is key that a ride has an equal balance of both in order for the ride to function and be fun.
Acceleration. Frequently confused with speed, acceleration is actually a change in velocity. Therefore, a roller coaster is accelerating through loops and curves even if its speed remains constant.
Friction. Friction is a force that can significantly slow a ride. Contact between the train and the air between the wheels and a track all impose friction on the ride.
How do roller coasters work in real life? As a roller coaster begins to come towards the first hill or curve, the force of gravity pushes them downwards as they can accelerate, gain more speed. As they gain more speed, their PE turns into KE, which is potential energy, and to kinetic energy. The further and faster they go down the hill, the more potential energy is converted into kinetic energy.
So if you look at the picture here, number 1 is the maximum potential energy at the start of the ride, so that would be at like your biggest hill. Number 2, maximum kinetic energy, just as the car passes through the bottom of a loop. Number 3 is each loop is slightly lower than the previous one because the car loses energy as it goes. 4, centripetal force provided by the track pushing against the car allows it to have the loop the loop. And number 5, the car has less energy at the end of the ride than at the start due to friction and air resistance.
Here are the videos of our roller coaster.
Okay, and now
This is the slow motion video.
we'll play that back.
In slow motion. We can take it slow.
Okay. Now our data. We measured our data in 2 different places on our coaster. We used gate machines with lasers that track when our cart passes through it in order to record our data. In spot 1, our velocity is 2.582 meters per second in 0.03606 seconds at a height of 0.465 meters. Our kinetic energy is 55.33 joules. Our potential energy is 75.65. And then in spot 2, the velocity is 1.31 meters per second, and in 0.05800 seconds at a height of 0.38 meters, and our kinetic energy is 14.33 joules, and our potential energy is 61.812.
Want to build a roller coaster too? Many aspects go into building a roller coaster. Learning and understanding the concepts before is key to be able to build one. This is an interactive virtual roller coaster which will help you attempt to build a roller coaster. Follow this link below. Thank you for a great year.
People, let me tell you about my best friend. He's a warm-hearted person who loved me till the end.
We're gonna miss you. Thank you. That's it.